Hi everyone, in this video lesson I'm going to show you how to work with the EtherChannel and which protocols are making negotiation of the EtherChannel. First of all, let's take a look for the situation where the EtherChannel can be used. Imagine that you are connecting switches between each other and you have the double interconnectivity between two switches. So in this situation, as you remember, to prevent looping, we have the protocol which is called the STP. The STP protocol is preventing the loop. So that if we'll review the functionality of the STP protocol, let's take a look for the situation where we have with you computer A and let's say computer B. Whereas computer A is making the broadcast request, and this broadcast request will go to the switch, and switch will resend this information due to that fact that this is broadcast to all other ports, excluding port by using which it received this broadcast. And at the same time, the information will go by using this way and by using this way. Well, let's say the switch 3 will resend the broadcast to computer B, and then this broadcast will come back again to the switch number 1, and this broadcast will impact computer B one more time, and the broadcast will come here. And as you see here, so here we'll have with you infinite loop on layer 2. So that is why, to prevent the situation, our STP will elect one of the switch as the root bridge, and according to the root bridge election, they will make a decision which port to block. For example, we have blocked port right here, and to prevent looping in this segment of the network, for example, we'll block our port here, so that when we'll have the broadcast communication from computer A, the broadcast will be distributed like this and it will never come back again. Oh, this is the role of the STP, and but imagine that you want to make connectivity between switches, and you want to have you don't want to have the blocked port. You want to work with double link, so that if you have speed of your connectivity between two switches 1 gigabit per second, so then if you will connect both of them, you'll have 1 plus 1 gigabit per second, which will give you in total like 2 gigabits per second. So in this situation, you have to use the EtherChannel. The EtherChannel is the technology which is providing you ability to create the virtual channels, like a tunnel between two switches, which are in which topology the links are working in the single group, so that you may just bound two of these links. And for switches, logically it will be one single link here and one single link here, so that for STP it will not be STP will not be required to block one of these two ports, because logically it will be a single link, or it will be just a channel 1, for example, and here will be also channel 1. Alright, so the EtherChannel is the technology which is providing you ability to connect multiple links between switches that will not be blocked. So we have two protocols which are providing the negotiation between ports of the switch to create the EtherChannel. They are port aggregation protocol, PAGP protocol, which is a Cisco proprietary protocol, and which can work only with Cisco equipments, and link aggregation control protocol, LACP protocol, which is IEEE 802.3 standard protocol, which can work with multiple vendors. And but in fact, these two protocols are making the same job, and they have different names in the port statuses, but the job which done by them are absolutely the same. Well, some restrictions of using the EtherChannel. So EtherChannel provides you ability to connect up to 8 links between each other, so that if you use the full duplex 100 megabits per second, 8 links, so then you will have 800 megabits per second of total speed. And in case if you are connecting 1 gigabit links and you can connect 8 1 gigabit links, then you will have 8 gigabits per second. This is the limit, the restriction of the Ether channel. And by the way, when you are creating the Ether channel connectivity between your switches, you don't have to create a single channel. I mean, you don't have to make a group of ports which have different speeds and different protocols which are in use. Like if you have in your ports which are working with 100 megabits per second, for example 1, 2, 3, 4, 5, 6, 7, 8, let us say. So when you want to create a single group of this from this set of ports, you have to be sure that all of these ports are working with the same speed. You have to be sure that all ports are working with same VLANs. You have to be sure that all ports, if they are trunk ports, you have to be sure that all of them are configured as a trunk port, and you have to be sure that all of them are configured with trunk which are allowing the same VLANs, or you will have a problem in your Ether channel creating process. Well, let's take a look for the PAGP protocol, PAGP. This is Cisco proprietary protocol, and it has it's sending information to from one switch to another switch every 30 seconds to evaluate, to understand that the neighbor switch is working. And what else? Also, it has. So if we'll take a look for the port statuses, it actually has 2 port statuses, which is desirable and auto. And whereas on is not PAGP protocol's port status. The PAGP protocol's port status only desirable and auto. And desirable port status actively asking if the other side can or will participate in creating the Ether channel, and auto is passively waiting for any offer, sorry. And in case if from one side there will be a desirable port and from another side there will be auto port, then they will have adjacency created and they will have an Ether channel. And here we have a table which is showing us that in case when we have 2 switches, like switch 1 and switch 2, and in case when you are configuring from one side or auto or desirable and from another side desirable, then you will have establishment of your Ether channel. So like if from one side you have desirable and from another side you have or auto or desirable, then they will have establishment of the channel. If from one side you will have on or auto or desirable, but from the other side, if it will not be configured, then you will not have the Ether channel. If you will have from one side on, so it's like if you will take a look for the port status on, it means that you are not using any Ether channel, you are not using any Ether channel negotiation protocol. And if from one side you have on, which is like a channel member without negotiation, and from another side if you will have desirable, then you will have no negotiation. I mean you will not have the Ether channel. Or from one side auto or on, and from another side auto, then no. So it's like passive and passive, then passive. So from one side exactly you have to have an active. So what does mean active? It means that desirable, and during the desirable port status, port is asking for creating the adjacency to create the Ether channel connectivity. Well, and if you don't use the protocol to create an adjacency, to create the Ether channel, then you just can turn on Ether channel on your ports, and then you will have a channel which will be created manually by you without any help of the protocol. Well, and we have absolutely the same situation with the LACP protocol, which is actually the standard protocol. And as you see from the description, previously it was the standard of IEEE 802.3a div standard, but the newest version is IEEE 802.1ax standard, which is stands for the EtherChannel protocol LACP. Also, it has two types of the modes. One of them is active mode, another one is passive mode. So it is the same as, so if we'll make comparison with the LAGP protocol, PAGP protocol, PAGP protocol, then it will be like a desirable, same as desirable, and same as, what was there? The auto. So like active and passive. And also we have on, which is not the part of the protocol negotiation process. So that when you have switch 1 and switch 2, which are interconnected between each other, they also, if you will disable the negotiation, EtherChannel negotiation protocol, and if you'll just turn on the EtherChannel from both sides, then you will have channel establishment. If you have from one side active, and from another side passive or active, then of course you have your EtherChannel establishment. And the same as in previous example with the PAGP, LACP reacts absolutely the same. On, active, passive with not configured, there is no channel. On and active, there is no channel. And passive with on or passive will not give you the channel, the EtherChannel. Alright, and some Ethernet configuration guidelines. To create the EtherChannel, you have to be sure that the ports are available to work with the EtherChannel, that they support the EtherChannel, because not all the ports of the switches available to work with the EtherChannel and to create the channel. Also, you have to be sure that their speeds are absolutely the same. So when you are working, for example, from one side, if you have speed of the 100 megabits per second, but from another side you have only 10 megabits per second, then EtherChannel will not be available to create the channel. Another thing that the VLANs have to match each other on both sides of the EtherChannel which you want to create, and the range of VLANs which are allowed on the trunk have to be absolutely same on both sides of the switches, or in other case your EtherChannel will not be formatted. How traffic is distributed in EtherChannel. From first sight you may think that, alright, so I created a channel and I have a virtual channel like this, so all my traffic which is traveling between computers will be distributed, like one will come here, will go here packet, another packet will come here, and third packet will go by this link, and the fourth packet will go by this link. No, it is not always like this. We have the traffic distribution in the EtherChannel, and it can be distributed by using the different types of the algorithms. By using types of the addressing, and they are the IP addressing by source IP address, for example, by MAC address, or by the ports of the fourth layer of the transport layer. And if we'll take a look for this table, let's take a look for this table. Here are the methods of the distribution the traffic. For example, we can distribute the traffic by using source IP address. So in this case, when you are distributing traffic by source IP address, and what does it mean? It means that if computer 1 wants to communicate with computer 2, how your traffic will travel from switch 1 to switch 2. Let's take a look for that. So your frame goes to switch 1, and then switch 1 think that, alright, where I have to send, through which link, through which port I have to send this frame, and it looks for the source IP address. And in source IP address we have last digit, last octet, which is equal to 1 here, so that it will be 1, 2, 3, 4, 5, 6, 7, and 8 in binary. And our switch will take a look for the last bit, which is equal to 1, and afterward it will make decision, alright, if you are equal to 1, then I will send you through link number 1, like this. And when computer 2 wants to make communication with computer 1, so let me change the marker to the blue one. So when we have such kind of communication, computer 1 sends, computer 2 sends the information to switch, and then things have to think about, oh, through which link I have to send this frame, and afterwards, if we are using the source IP address as the method of the distribution, the traffic in the Ether channel, then computer will take a look for a number 46, which will be equal to, sorry, let me just convert this number, 4, 8, 16, 32, and 64, and 128. So to have the result of 46, we have to take 32, and we have to add 8, which will give us 40. So it will be like 0, 0, 1, 0, 1, 0, and I think that we have to take 1, and here we have to also take 1 for number 4. So, and as a result, we will get number 46. So it will be 0, 0, 1, 0, 1, 1, 1, 0, and as a result, the last bit, which will be equal to 0, will define that through which port our switch 2 will resend this frame. So our frame will be resent by using this link. So in case if we are using source IP address in distribution of the traffic through the Ether channel. What else method we can use? We can use the destination IP address, or look, we can use the source and destination IP address. We can use source MAC address, we can use destination MAC address. It's the same as we used it in source and destination IP address. And now we have to just pay attention for the source destination IP address and for source and destination MAC addresses. So here you can see the hash operation, which is equal to the XOR. And what happens when you are using source and destination MAC addresses? Let's take a look for this example. First of all, we have to define what XOR is equal to. So when you have two variables like variable A and variable B, so the result of the XOR of variable A and the variable B will show us this table. 0 XOR 0 is giving us 0. 0 XOR 1 gives us 1. 1 XOR 0 gives us 1, and 1 XOR 1 gives us 0. So you have to remember what XOR function is looking like, is what it is working like. And now let's take a look for first example. In first example, we have hashing use source and destination IP addresses, and which port will be used during the communication between computer 1 and computer 2. So we will take a look for the two binary strings of our IP addresses. And by the way, we are using source and destination. So then we have this source and we have this destination. Well, all we need to do, we need to just make a XOR operation between these two rows, and we actually need to make XOR of 1 and 0, because we have only two variants, 0 or 1. So as a result, 1 XOR 0 will give us alright, so will give us here it is, it will give us 1. What does it mean? It means that communication between computer 1 and computer 2 will be done like this. So if computer 2 will give reply, what will be happening? We'll have vice versa situation, 0 XOR 1, which will give us same result as 1. So in this situation, when we will have communication between computer 1 and computer 2 through our Ether channel, we will not have a normal balanced communication. So all of our communication between these two computers will be happening through the same link. Example number 2. Now we have 3 computers, and whereas PC1 and PC2 use link 1, which we already defined it with you, so from this example. And now let's define which link will be used between PC1 and PC3 during their communication? Well, to answer for this question, we have to just take the binary streams of this number and of this number, and afterward we have 1 XOR 1, which is giving us the result of 0. Then it means that communication between PC1 and PC2 will be happening through link number 0, like this, and communication between PC1 and PC2 will be happening through link number 1. So, and in this situation, our EtherChannel will give us a normal load balancing, which will increase the speed of our connectivity between different hosts. And example number 3, in case of aggregating switches with 8 links, switches use last 3 binary digits of IP address or the MAC addresses to define one of the 8 variants. And so actually we don't have this example, but I'll just show it by drawing it. So imagine that we have switch 1 and we have switch 2. So let me even change the size of these two switches, because I need to be interconnected between these two switches by multiple links. And it's going to be like link number 1, link number 2, 3, 4, 5, 6, 7, and even 8 will be like this. So that each port will, each link between these switches will have its own unique number, like 0, 1, 2, 3, 4, 5, 6, and 7. From 0 to 7, it will give us 8 combinations. So, and to define through which port we have to work, in case if you have computer A which has an IP address like at the end it will be 1, and another computer which will have an IP address at the end of 2, the IP address. Then if you'll convert this 1 into the binary, you will have a result 1, 2, 3, 4, 5, 6, 7, and 8. And 2 will be looking like 1, 2, 3, 4, 5, 6, 7, 8. So, and to understand through which port you have to send this information if your communication happens like this, switch 1 will think about it like this. So it will take this 3 bits and it will take this 3 bits. Okay, and we'll have 0, 0, 1 and 0, 1, 0. So as the result, now we have with you 1 XOR 0, which is giving us 1, 0 XOR 1, which is giving us 1, and 0 XOR 0, which will give us 0 as a result. So, and our information will be sent now. If, by the way, if we are using source and destination IP address, then in this case, which link will be used? It is equal to 0, 1, 1. If you convert it to the decimal, it will give you number 3. So that your communication will be done through link number 3. So it will go like this. Here it is. How to configure the load balancing? So you just have to write in global configuration mode port channel, load balance, and afterward you have to define one of the methods like source IP address, or you can write destination IP address, and so on. So you can just select one of this method, but you have to mention that not all of the methods of the load balancing are supported by all the switches. By the switches of the Catalyst 29 and 35, they are just supporting source IP, destination IP, source MAC address, destination MAC address, and source destination MAC address, source destination IP address. They are not supporting source. They are not supporting work with the ports numbers like source or destination port numbers, because they are not working with layer number 4. This is the end of the part 1. In next part I'm going to show you how to make configuration of the EtherChannel on Cisco Catalyst switches.